We are ready for the next talk in just a moment.
Sorry.
All right. So, for the next talk, we have two speakers. We have Paul and Katie with a talk on authorship attribution. Is it Shakespeare? Please welcome them on stage.
Thank you. I'm a lecturer in English at De Montfort University in their Centre for Textual Studies.
Microphone. Sorry. You need to stay close to the microphone.
Okay.
Over there.
Okay. Is this all right from here? Yeah? Great. A lecturer in English at De Montfort University's Centre for Textual Studies, where Katie Jones is a graduate student, and we both work on Renaissance drama and early modern theatre history. We are both more or less total beginners with Python, and we're very grateful for PyCon having us. Our talk today is concerned with how two literature specialists can use Python to answer questions about the Renaissance theatre. That is, the theatre of William Shakespeare, of Queen Elizabeth I, the 16th and 17th centuries. Knowing that not everyone spends their lives squabbling about events from 500 years ago, and knowing that people spend even less time wondering what computer programming can do to help answer our questions, our talk begins with a brief primer on Shakespeare's theatre and authorship in the period. We go on to discuss how two simple Python programs can be used to generate new knowledge about old plays, and particularly how such programs can help us peer back in time to determine who wrote surviving plays. We were brought to this approach using Python to answer historical questions about theatre practice and authorship because of a desire to make sense of data from hundreds of plays all at once, and a desire to count and process things that would take a lifetime to do manually. We are a rarity in our field. Even scholars who engage with mathematical and quantitative studies do so semi-manually. They might query a digital database, but they process their results and write calculations by hand in spreadsheets. Or they might do their pre-processing by hand before letting out-the-box tools do calculations for them. We reflect on this at the end of the paper and why we think our approach, learning the code and writing the programs, is a better way for answering our questions, why it improves us as researchers, and why we think everyone should be doing it. I said to say thank you to PyCon for having us and welcoming beginner programmers, but you might regret it in 20 minutes' time.
So, hey guys. So 450 years ago, people started building theatres in London. This was the first time anyone had done such a thing since the Romans. It was a radical thing to do, and it prompted perhaps the most extraordinary artistic flourishing that this country has known. This lasted from somewhere between 1570 to 1642, when the Puritans, ever the enemies of fun, closed the theatres at the outbreak of the Civil War. These theatres staged plays, some with familiar names, like Romeo and Juliet, Othello, King Lear, and some with names you have never heard, The Costly Whore, A Hard Shift for Husbands, The Twins' Tragedy. These plays were put on by companies of actors, grouped under the patronage of aristocrats, and usually based at a particular theatre. The actors were all male. Men played the male parts and boys played the female parts. And rather than play one play day after day, like we do now, they used a repertory system where they put on a different play each day. This fact specifically, as well as a burgeoning industry in general created a demand for new plays. We do not know for certain, but theatre historians estimate that there were several thousand plays written and performed in this period, and something around 3,000 seems a good guess. Historians do not have 3,000 plays to work with, though, as not all of them have survived. We know some information about 1,100 plays, maybe their titles, possibly some plot detail, maybe their authors, and about 500 survive in some printed form. More than 300 of that total are anonymous, and for tens of the printed plays, we have no authorship attribute information. Even where we know some authorship information, some might still be concealed. About a quarter of the plays written for the London stages included about a quarter of Shakespeare's were written by more than one person. There seems to have been some suppression of this fact when the plays were printed. It is difficult to know why, but almost certainly that there are plays we think of as being written by one person that were actually written by two or more. We return to the problem of unknown authorship in the second half of this talk, but here we ask what to do with the data from all of these plays. Just to give you a sense, with 500 surviving plays at roughly 20,000 words to play with, we have about 10 million words to read. At an average pace, this would generally take about 20 working weeks non-stop, and historically, accessing this data has been difficult. These books of these plays are almost all stored in research libraries around the world. Handling them in person is time-consuming, it's expensive, and it needs a special skill. Since the advent of personal computing and the storage of text in digital form, accessing them have become a lot easier. In 1998, Chadwick Healy launched Early English Books Online, a major commercial database that pairs page images from the plays with transcriptions. Researchers often make use of the page images, but less so with the transcriptions. The first program that we showcase today uses these transcriptions wholesale. Colleagues in literature departments are reluctant to harness the power of computers to aid their research. They can see the benefits of the page images and even the transcriptions of the play in which they are interested, but someone suggesting they could widen their gaze to cover the whole canon all at once is too much. Traditional methods of close reading, looking carefully at one section of one play, persevere. But such an approach cannot answer certain questions. When we met to discuss my project about an anonymous play, The Costly Whore, we began talking about the treatment and position of whores and prostitutes in the period's drama. There was little published to refer to, and we could think of odd examples of characters from plays we knew, but we had no way of developing a survey view. That is when we turned to Python. We won't bore a room full of programmers with our painful iterations of the most basic programming, but we will share a quick process of what we devised. Being wholly new to Python, everything was a discovery. We thought one useful way to assess the treatment of whores and prostitutes would be to work out the terms used for them, and with that information in hand, compute how often each term was used. Here they are. Obviously not derogatory in the slightest. We stored these in a list, and using a set of loops, I targeted and processed a sample of transcribed early modern plays for analysis. I used the glob module to turn the file names of the text in a given directory and pre-processed each of them using the code here. The final line split each play into a list of its constituent words to be compared against the list of whole words that we have already seen. Using this conditional expression, I could compare the words I was looking for with every word in the text I wanted to examine. I struggled for a time, though, with just how to store the output of this expression. It was all very well to print something to the console each time I got a match, or to increment a count variable, but how to do it for multiple words in multiple plays, possibly across multiple genres. I can see some of you smiling at the code. A series of dictionaries nested one within the other came to my rescue and meant I could store values against specified keys using the same loops for the comparison. From here, I wrote data to a .csv file. I'm not yet equipped for full-blown data analysis in Python, but the results this program generated were more than enough to answer our questions about whores and their treatment. I learned, for instance, that nearly half of the references to whores and prostitutes occur within the plays we generally call comedies. Comedy in this period does not mean comedy like we use it today. Think of a comedy as a play that does not end in a bloodbath or does not centre on kings. And rather disappointingly, I found that my play, The Costly Whore, despite the title, does not use the word whore at all. The benefit of this approach meant that almost instantly I could turn my program to answer other questions about other plays. How often are kings referred to in history plays versus tragedies, say? Or how many times are witches mentioned in the drama? And with a little more work, more complex questions could be addressed. How often are kings mentioned in a section where there is no corresponding mention of queens? Getting to grips with the nested dictionaries proved vital for the work on authorship that has followed. The same method was applied to store authorship data before restructuring it for mathematical analysis, to which we now turn with Paul.
Many of those printed plays whose transcriptions Katie was working with come to us with incomplete information about their authors. A typical title page of a play in the period looked like this. The title of the play typically appeared, sometimes the name of the acting company who had performed it, possibly the theatre, and maybe even a little blurb, a little teaser line is used as marketing material for potential buyers. This matters to us because the title page now is the main source of authorship information about a play. Scholars interested in the period and its plays have been searching for lost authorship information for over a century. Where Shakespeare is concerned, it's been going on for far longer. Some of this has been physical searching, burrowing into the libraries of stately homes, document troves at research libraries, just about any document anyone can get their hands on, particularly if there's a sniff of having Shakespeare written on it. And since we've had these texts stored digitally, that search for authorship information has meant that we no longer need to rely on finding some new document to tell us something new. People can query large databases of digital texts of these plays. And this means we've increased investigations into their authorship and discovered new methods for approaching them. This field, in general, has become known as authorship attribution, and I should say here, it is every bit as petty and full of ego and squabbling as you've ever imagined academic fields to be. Not us, though. Authorship researchers can now query databases of all the period's plays, looking for things that they think are indicative of a person's authorial style. And think of authorial style like your fingerprint. It's unique to you. The method I'm talking about today, and that the Python program we're about to see being discussed performs, is one that looks at an author's use of function words. These are the glue words in our language. They're about 50% of everything we say, but we don't really think about saying them. Of, it, the, in. And recent mathematical work has shown us that we should be paying a lot of attention to the way function words are used if we're interested in attributing authorship. This is important because for a long time, researchers kind of thought the opposite. They seemed to go, or people went searching for long strings of words matching in multiple works, in the expectation that if someone favoured a particular phrase, they might be likely to use it again. And they were particularly interested in lexical words, words we think of as carrying meaning. The other benefit to this turn to function words is that we have a lot more of them. Here's an example of what function words can show us about authorship. This graph shows the works of three prominent, and I'm careful with that word because I mean prominent in the field of Shakespeare studies, so all things are relative, prominent authors and their use of the words and of. Just by looking at these two words, we can discriminate between their works. If we do this for those 100 function words, say, this becomes a really powerful discriminator. As I mentioned, this is a welcome revelation because it means we've got more data to work with. Rather than searching for those matched long strings that rarely occur, we've now got hundreds and hundreds of these and tos and ofs to search through in every play. It also, this focus on function words, confounds traditional objections to the quantitative, which in our world happen very regularly. People often say, how could you tell the difference between two authors? One might have been mimicking the other. They might have been writing in the style of Shakespeare. Well, you try counting up how many times Shakespeare uses thou every 100 words, and then writing that same rate of thou in your writing, and then doing that for every function word. Becomes really, it's impossible. One of the most powerful methods for determining authorship using function words is based around counting and scoring the proximity of them. And it's called Authorship Attribution by Word Adjacency Network. And it was developed by a team of electrical engineers at the University of Pennsylvania and first used a couple of years ago in the study of early modern drama in collaboration with a colleague of ours at De Montfort University, Professor Gabriel Egan. They processed some of their work using C, which just won't do for us. So I set about copying it in Python. Mathematically, the method and its output look like this. And this is the point in literature conferences. At best, you get mumbling and sort of, and at worst, people walk out wholesale. And you'll notice a couple of slides ago, I've used up my sort of graph card. You get away with one. More than that, and you don't get taught, you get served lunch last. What this equation does, and what the code I've written does, calculates the relative entropy of two pieces of writing and scores their similarity. A low score means two pieces of writing are very similar. A high score means they are quite dissimilar. The lower the score, the better chance that they share the same author. We begin by taking a text and determining the function words we want to examine. To demonstrate, I'll use the same example as the UPenn mathematicians. Let us look at with, and, one, and in the following texts. The first time we hit a chosen function word, with, in that first example, we set up a window that contains the next 5 words. If any more of our target words occur in those 5 words, we score it as a 1 and make a note. We then move to the next function word in the text and set up that window again. Once more, we count the function words. When we hit a function word for the second time, see 1 and then 1 again in that first line, the scores add up cumulatively. This leaves us with a network diagram that looks like this. And this is what the authors call a word adjacency network. There are 2 other steps performed with the network in this form before we're ready to apply some mathematics. The first is to actually give a descending scale score. So rather than everything scoring 1, you only score a 1 if the function word you find occurs in the first place of that 5-word window. It scores a little less if it comes in the second place and a little less in the third place. The other thing we have to do is turn these weights, these scores, into percentages of everything coming out of a particular node. And these steps place more significance on the most proximate function words, but then they also serve to not privilege longer text. So longer texts don't have more chances to score more highly, more function words close to one another. And then we repeat this for a second text. I'm hoping at this point you're partly with me and partly scratching your head. I went about programming this in much the same way. But I started in the way that Katie began with her program. I imported text files, I processed them and then split them, each text, into a list. I had a list of function words to be examined and used a conditional to check whether each function word matched the word being looked at in the play files. We pick up the program with it assigning scores to words after examining the 5-word window. You can see, and don't worry much about the names, that I'm employing a series of nested dictionaries to hold the scores. You can also see, and I'm wincing as I turn to look at it, that there must be a simpler way of applying these descending scores. And I toyed with not including it, but I cannot see how. I fiddled around a lot with it, but there must be something. The next steps for the program and for the method include comparing those percentage weights of different edges in our two pieces of writing and subtracting their natural logarithms one from another, multiplying that result by the weight of one of those edges, and then multiplying that by the limit probability for the network that we have devised. And that's because that network that we've created is then, we render it as a matrix. And it's by multiplying that matrix by itself many, many times that we develop the limit probability. I won't trouble with more of the technical detail, and I don't mean that's not a snub to the audience, that's a snub to my inability to explain it, but I'll focus on moments that might be of interest. I developed this code over a period of weeks, tackling those equations that we've just seen and the author's explanations bit by bit, and learning the new techniques as I went. I would hit roadblocks and then have to puzzle out the next step with only the toolbox of a beginner coder. The first sticking point I found is that every time the example called on some new data, I found I'd overwritten it previously, thinking I didn't need it, which meant lots of repeated work with those nested dictionaries. And I spent longer than I care to admit trying to copy dictionaries and change the values of one but not another. And so I'm eternally grateful to the deep copy method, which I discovered after a lot of Googling. Another way was to use pandas and numpy to do the program's mathematical heavy lifting. A final tool in producing the relative entropy scores was being able to sum the values of a dictionary. The happy thing to report is that the method works in a way that we would expect. There are still kinks, but if we compare two plays by, say, Ben Jonson, we get a very low relative entropy, suggesting little difference between the writing. But a Ben Jonson play and a Shakespeare play give a much higher relative entropy, suggesting a much larger difference. Tackling problems like these using Python has made us better historians of the Renaissance. And we say this as members of a field whose response to the digital revolution has been to use email and download a few PDF files. Nothing helps you formulate a research question like knowing you must go away and program a computer to find the answer. And nothing helps you better understand a complex method than coding it line by line, getting frustrated when it does not work, and being euphoric when it does. Such things, we think, are vital, and we encourage students and colleagues to approach them in the same way. we would have fewer answers to questions about the Renaissance theatre were it not for Python. Thank you.
Okay, we can break for lunch now. The mic is still off. Are you going to be around for the rest of the conference?
Absolutely, yeah, we're here.
If
Yeah.
you have any question on Shakespeare and linguistics and everything,
Yeah, feel free to grab us now, lunchtime, next couple of days, whenever. Yeah.
please let's take time again.